Alright, so I'm going to try to go through some of the most asked about questions off the homework. If I don't get your question answered, please come see me before the test that's going to be on Thursday. So please come ask me some questions. I'm going to try to get through as many as I can that will help you out off that homework. If you want to email me and I can do them on YouTube while I'm at home, that'd be great too. Just email me and say, hey, Mr. Harrison, can you do number 6 or whatever? Just let me know if there's something that you want me to do. One of the most common questions I get off of that page 488 homework is number 10. Number 10 is a weird looking guy because it looks like something that Mr. Harrison didn't even show us in class. But if you look at this, 125 on the bottom of the fraction really is the same thing as 5 to the third on the bottom of a fraction, which means that could be moved to the top of the fraction, just like we do with negative exponents. You move them and make them positive. You could move this positive exponent up and make it negative, because 5 to the negative third is actually 125 on the bottom of the fraction. Sorry, 1 over 25. 1 over 125. I'll get it right eventually, right? So when we take this, now I have the same base on both sides, so that means 3x would have to be equal to negative 3. Divide by 3 on both sides. Negative 1 would be my solution. Another one that people tend to ask me about would be number 22. Number 22, you have 2 raised to the 3x minus 4 power equals 5. And you are supposed to solve this. Well, on the right-hand side, you can't get this to be the same base. So this is where that whole definition of a logarithm thing comes into play. This is base 2, so I can do the log base 2 of 5 is equal to 3x minus 4. But I am going to have to be really careful with this, because I'm going to have to add this 4 over to this side. But this is not going to be added to the 5. Really, that 5 is inside the logarithm, so to speak. Then we divide by 3 on both sides. And I'm going to have to do a lot of work in my calculator here, but I'm going to have to make sure that when I do that, I also go through and take it step by step. Don't try to do it all at once in my calculator. Because to get the log base 2 of 5, I'm going to have to take this, I'm going to have to do the log of 5 divided by the log of 2. Go ahead, and once you do that and press enter, then add your 4 to that. So then push plus 4. Then take that and divide by 3. So then push divided by 3. And it will constantly update that answer for you as you go down through there. So you get 2.107 when you answer that problem. 2.107. So then probably other than that, the section there around 24 through 31, I know I gave you some of those. I think what had happened was I had written down a couple of those 24 through 26. It said solve by graphing. I didn't really want you to go through and solve by graphing, but you could solve those using your normal methods. So don't worry about that. You're not going to have to solve anything by graphing on those. As far as what you would do is the stuff on the calculator, you could enter both of those equations into the y equals screen, and you could take it and you could actually graph both things, both the left-hand side and the right-hand side of the equation, and see where they intersect each other, which is what we have done before, where you find the intersection of two lines, like we did systems of equations. So I don't want you to have to worry about that. So what I want to skip to actually is number 31. Number 31 says, you have this equation that's y equals 6.72 multiplied by 1.014 raised to the t power. And this is supposed to model the population, and it has the x power actually, but I'm going to use t for time. Models the world's population in billions of people x years after the year 2000. Find the year in which the world population is about 8 billion. So you want to find when this thing equals 8. Notice that the population is growing by about 1.4%. Remember, if you take that 1 plus the rate here would be 0.014. Move that decimal place, 1.4%. There's your little bit of extra review there for your test. So when you want to solve this, you divide both sides by 6.72. When you divide this side by 6.72, you're going to get 1.014 to the t power equals 8 divided by 6.72. Take out your calculator. 8 divided by 6.72 is going to be an ugly decimal here. Remember what I told you about that. You want to take that and do math, enter, enter. Change it back to a fraction of 25 over 21 because that will keep you from messing up and rounding too early in your problem. Then you've got this now set up exactly like this guy over here where we did the logarithm rules, the definition of the logarithm to get this into logarithmic form. So you do the logarithm base 1.014 of the 25 over 21 equals to t. This base raised to this exponent equals this number. And so then all I have to do is take out my calculator, do the log of 25 over 21. That's going to be the whole logarithm on the top part. And then on the bottom, I'm going to do the log of that base number. So I'm going to do divided by the log of 1.014. Got to be a little careful with that because there's so many numbers floating around there. Press enter and it says 12.54. So your time is approximately 12.5 years. But the question says find the year in which the world population is about 8 billion. You got to remember that this was talking about time 0 is actually the year 2000. So 12.5 years later, you're really talking about in the middle of 2012 is when this guy will be a population of 8 billion. So in the middle of the year of 2012. Okay, so the next one I want to take a look at is number 40. Number 40, you have this log of x minus log of 3 equal to 8. And you're supposed to solve this equation. You need to condense these two logarithms into the log of x over 3 because remember that's what subtraction between two logarithms tells me. When I condense it, it's division on the inside. And then you have this. Then you're supposed to take this and the base 10 raised to the power 8 equals x over 3. And it's not real pretty, but you've got x is going to be 10 to the 8th. Sorry about that. 10 to the 8th multiplied by 3. So when you take 10 to the 8th and you multiply it by 3, really this you could leave it in that scientific notation that you guys have probably seen in some of your other classes, 3 times 10 to the 8th power. Or you could take it and say 3 and move that decimal place over 8 places. So right here. So you're looking at 300 million will be your answer for this problem. All right, so now we're going to take a look at number 44. And number 44, you have 3 times the log of x minus the log of 6 plus the log of 2.4 equals 9. So you got a lot going on here, but you can condense these down to one logarithm. So you're going to take it and you can take this guy and you can condense it down to the log of x cubed over 6. Moving that into the exponent and dividing because of these two. Then you can take these two guys right here, condense it down to the log of x cubed times the 2.4 over 6, because remember when you multiply in fractions, multiply straight across. So it's going to be 2.4 x cubed over 6. I know that's not real pretty as a fraction, but I'm going to leave that for this one just because I got that x involved too. I'm not going to mess with anything with that. But you could also take it and simplify it in your calculator. It can help you out there. Just make sure, guys, that when you're looking at this that you don't overthink it too much. Go through and use your condensing skills and then use your definition of your logarithm. Don't try to think about this too much right ahead of time. We're going to get to solving this in just a minute. So The base here is 10, so 10 to the 9th power is this stuff here, 2.4x cubed over 6. A lot of times what people will do too on this one is they'll also try to forget about the base. Make sure you're paying attention to what base it is. If it's a different base, you just use whatever numbers down here. I know a lot of these in the homework were base 10. I don't like the fact that the book does that, but as long as you know this base raised to this exponent equals this, you'll be fine when you get to the quiz, or excuse me, the test next time. So, when you take a look at this guy, you want to multiply by 6 over 2.4 and get x cubed. When you multiply this by 6 over 2.4, we might have a problem in our calculator. We'll check it. Let's take 6 over 2.4 and multiply that by 10 to the 9th power. This might still be too large of a number. Let's check and see. No, actually worked out pretty well for us. So we've got the number still pretty big, right? So you got here, it's 2.5 billion is what it actually is. So this is 500, I'll put my commas in here, 000, 000. That's what that is when you multiply by 6 over 2.4. And then you're supposed to take the cube root. Because it's x cubed, that's the opposite of x cubed, you take the cube root. So you take this and you raise this answer right here to the 1/3 power, or you can take the cube root of it in your calculator if you want. I'm raising it to the 1/3 since I already have that in my calculator as 25 billion or 2.5 billion. That way I don't have to actually go in and type it again. I just raise it to the 1/3 power, and it's 1,357.21. 1,357.21 approximately. Okay. All right, the last two I'm going to look at off your homework are 67 and 69. I'm also going to take a look at one extra problem. I'm going to show you one more type of problem that you might see on the test to help you out. And then I'm going to go through and you can start looking at your review on here, and I'll explain a little bit how to do that in just a second here. So this one, 67, you have base 10, so 10 to the 2nd power is equal to x squared. So this is 10 to the 2nd power is 100. Take the square root on both sides, and x equals plus or minus 10. On this one, neither one of those are extraneous. I know we talked about extraneous solutions here, but neither one of those are extraneous because when you plug in negative 10 into here, it's x squared. Negative 10 squared is going to be 100. So negative 10 or positive 10 will work. Both of those will work for that problem. Number 69, you have log base 8 of 2x minus 1 is going to be equal to 1/3. And this is going to be this base, 8 raised to the 1/3 power equals 2x minus 1. If you remember, the 1/3 is the cube root. We just talked about that a second ago. 8 to the 1/3 power is 2. 2x minus 1 over here, so you add 1 is 3. Divide by 2, and x is going to be 3/2. All right, one last thing with equations is if you see something like this, log base 2, let's say x plus log base 2 of x plus 2 equals, let's go with 3. You have like bases there on those logarithms, so you can condense those logarithms. When you're solving this equation though, don't stop once you condense them. Make sure you actually solve the equation. So you multiply, when you do log base 2, condensing these two together, you do x times x plus 2, so that gives me x squared plus 2x when I multiply those together. Then I do the same thing I did on these logarithms over here. The base raised to the exponent equals the power, but I do 2 to the 3rd power equals x squared plus 2x. So that's going to give me this base raised to this exponent equals this. It gives me a quadratic equation that I'm going to have to solve. So guys, when you solve this quadratic equations, don't forget all the other stuff that we've done. Factoring, quadratic formula, none of that stuff has disappeared. It never has. So you've still got to be responsible for that. So when you subtract that 8 over on this guy, we have minus 8 there. You can factor this one. This one actually factors pretty well because you have x plus 4 and x minus 2. That will give me the 2 in the middle. That gives me two solutions of negative 4 and that gives me a solution of positive 2. When that happens, negative 4 will not work in the original equation up here, because if you plug a negative into this or this one, it's going to make that be a negative inside the logarithm, which you cannot have a logarithm of a negative number. So this one doesn't work, so it would be what we call an extraneous solution. This one right here is the only one that works. So when we look at this guy, if I started out my problem, and tell you what, I'll just highlight it. If my problem started out looking like this right here, so if I did not have to condense these two, if that was not ever in the problem, negative 4 would actually work, because negative 4 right here would be 16 minus 8 here, so that would be a positive number in here. You could still plug this guy into this one. So make sure you realize that it depends on what the original equation looks like. If you can plug in this number into the original equation and it works, then that means it's not extraneous. But if the original equation you plug it in and it doesn't work, that means it is extraneous. So be careful with that when you're looking at those that involve extraneous solutions. Okay, so what we're going to do now is we're going to do our test review. I told you guys last time you can probably play a little bit of a game, and so what I want you to do is you need to get into your groups, and you need to make sure that you are taking this seriously. And because I won't be able to be there to keep score, and I don't know if I can trust you guys or not, maybe I could. I'll let you guys try to keep score anyways. Each question is just basically going to be worth a point. So if you want to see who's the winner, whoever gets the most questions right is the winner. So Rachel is going to be in charge of dealing with the mouse and deciding when to rewind and when to pause and all that stuff. But I will say this: when I go through and I put the problem on the board, when I say pause, you probably want to pause it pretty quickly, because I'm going to put the answer up there without going through and doing a huge explanation of it. I'm going to try to help you guys get through as many problems as I can, and then you can pause it on the screen that has the solution on the board so you can see what happened. I may explain a few things about it, but I'm not going to spend a lot of time going over the explanation, because I want to try to get through as many problems as possible during this review. So get into your groups, make sure that you've got paper, make sure you've got a calculator, make sure you've got your pencil to help you out, and make sure that you guys are focused in on the problems that are on the board. It's a competition to see who wins, so make sure that you're trying to really actually pay attention and do well. This is also getting you ready for your test. Alright, so pause it right here. Alright, so here's the first 3 problems. I want you to know if it's growth or decay, and I want you to find the percent of increase or decrease. Pause it. Here's your solutions. Growth on the first one by 200%, because that's 1 plus 2 in the parentheses. Decay on the second one by 16%, because you're decreasing by 16% off of 100%. And then the last one's also decay by 12.7%. Be careful with your decimals on that one. Alright, here's your next problem. Graph this function. Make sure that you have every point correct and you have one extra other thing on there. Pause it. And here's your solution. If you don't have the asymptote at -4 because that graph moved down 4 spaces, and you didn't move your graph left 1 and down 4 with all those points from the parent function, your graph is wrong. Alright, here's your next question. You deposit $6,000 that you get as a signing bonus at work. You deposit into a retirement account which earns 8% interest, which means you're going to earn a little bit more interest because you're investing a little more in some high-risk stocks maybe. How much money are you going to have when you retire after 30 years? Pause it. Here's your solution. Make sure that you realize if I ask you to write the function, that you need to have that portion up there that says y equals 6,000 times 1.08 to the t power. That's the function. The solution to this problem after 30 years is $60,375.94. Okay, the next question is, Same retirement account, $6,000, 8% interest. How long before you have $24,000 in your retirement account? Pause it. All right, so here's your solution. You solve this much like those equations we were talking about earlier in class. Make sure you realize, though, the time is 18.013 when you find that solution for t for that exponent. But 19 years, you'd actually have to leave the money in the bank account, because if you're adding this interest once a year, you're not going to get it at the beginning of the year. So to get that full 24,000, to actually have that much in there, you will have a little bit more than 24,000 at the end of that 19th year, but you'll definitely have to wait till at least then. All right, here's your next problem. It's a half-life problem. You've got substance Z. It's the zombie virus. There's 1,000 milligrams of it. 13 years is the half-life, so half of it decays after 13 years. How much is left after 180 years? Pause it. All right, so here's your solution. Remember, half-life's always decay, 50%, but you got to take that number of years divided by your half-life, 180 divided by the 13, because that tells you how many times it cuts in half. So you're left with 0.0679 milligrams. All right, use your calculator. Use that function that we talked about on the calculator to find the best fitting equation for this one. Pause it. All right, so here's your answer. Y equals 0.3 times 4 to the x power. I am going to show you how this one happened, because a lot of people tend to have trouble with this particular method on the calculator. So you go, remember, to the Stat menu. Go to Edit, and this is where you type in your list. Now I'm not going to show you me typing in this whole entire list, just because that takes a little bit too long. But 1, 2, 3, 4, 5, and 6 are my x values from my table. And then I've got 1.2, 4.8, 19.2, 76.8, 307.2, and 1,228.8 for my y values in my table. I will have these cleared out, and they should be good to go. As long as you hadn't messed with your own calculator, you should have a list 1 and a list 2 to plug these into. Then remember, after you plug them into Stat, you go to Stat Plot, which is above the y equals. So hit second y equals, and it takes you to this menu. You need to make sure this is on. If it is off, then you need to come into this menu, highlight the word on, and turn the thing on by pressing enter. Make sure your X list is list 1 and your Y list is list 2. Then you go to graph. Now your graph may not look exactly like mine, because I've already got mine zoomed in. Remember, the next step is to zoom in on those points by going to Zoom Stat. So you plug them into the Stat menu. You go to Stat Plot to tell them to turn on. And then you go to Graph and go to Zoom Stat to zoom in on the points. Then you have to look at it. Guys, remember, I warned you ahead of time. I may throw something at you that is not exponential. I threw an exponential function at you on this one, but I may have a linear equation on here, or a quadratic that looks like a U shape. Notice this has that ramp shape, just like an exponential function. So I go back to Stat, go over to Calculate, and remember, the REG stands for a regression line, a best fitting line. So you go down this list until you find the one that you need. If I give you a linear one, choose the one that says linear regression. If I give you quadratic, choose the quadratic. But since this one was exponential, I'm going to choose EXPREG. Press enter once, gets you back to the normal screen. Press enter again, actually finds the A and the B to the X power. Make sure, though, that when you answer it on the test, that you actually write it out as 0.3 times 4 to the X power. If you do not do that, you are not giving me the equation. You're just writing down what the calculator had on the screen. So make sure that you write it out as 0.3 times 4 to the X. Notice that this one is a growth function, and my growth rate on this will be 300%. So there's a little bit of extra review for you. It's quadrupling every single time. So that's why this thing jumps up to such big numbers, even though it has a small beginning amount right here. All right, here's your next equation, or next question, excuse me. On this one, you're going to be finding the inverse of both of these functions. So there's 2 questions here, 2 points involved in this. Make sure that you remember what we talked about in the last chapter about finding the inverse of these 2 functions. Pause it. All right, so here's your answers. On the left, switch the x and y, solve for y. Use that knowledge that you have of the fact that this base raised to this exponent equals this stuff. And then you will be fine because it's the same thing we did when we were solving equations when there were just numbers involved and not y's and x's and everything all over the place. On this one, same thing, switch the x and y, subtract the 2 first, and then use that knowledge. This base raised to this exponent equals this number, so the log base 3 of x minus 2 is equal to y minus 4. Add the 4 over, and boom, there's your inverse. Remember I talked about this when we were doing the first day of the logarithms, and I told you one of the things that I like to do, if I have to graph a logarithm, I like to find the inverse and graph this one and then just switch my x's and y's because it makes it easier, because graphing this guy right here is going to be a whole lot easier than graphing this guy. But you can also simplify it even more if you even just ignore the plus 3 right here. Graph the log base 7 of x by doing the inverse of 7 to the x power and then moving it to the left 3 spaces, which is what's going to happen if you take this graph, which is exponential, down 3, and it's going to look like this logarithm that was moved left 3. Remember, because it switches those x and y's, it also switches from a horizontal asymptote on the exponential to a vertical asymptote on the logarithmic. All right, here you go. So here's 6 problems, 6 points up for grabs. When you're looking at this, remember, evaluating the logarithm, you're just finding the answer for the logarithm. Use that definition, though, still to help you out. Pause it. All right, so here's your solutions. Most of these should be pretty quick, pretty easy, especially ones like the down at the bottom. The logarithm of 1 is always going to be 0, or the logarithm of the base itself is always going to be 1. But the one at the top right up there, log base 12 of 144 to the x, make sure that you remember that 144 is 12 squared, but when you have a power raised to a power like that, that's going to give you 2x. So your answer is actually 2x. It's not 2 to the x power, it's 2x, because 12 to the 2x power is how you would get 144 to the x power. All right, next question. Expand this logarithm. Pause it. All right, so here's your solution. 1/2 times the parentheses log base 7 of x plus the log base 7 of y, because those two were multiplied inside a square root. That's why the 1/2 is the exponent that I moved to the front. And then minus, because it was divided by 2 times the log base 7 of z, it was divided by z squared, so that's where that ends up. All right, so here's your next problem. Condense these logarithms down to one logarithm. Remember, just go backwards from what you did with expanding. Pause it. All right, so here's your solution. The natural log of 3 times the cube root of y over 2 times x. You do each parenthesis separately, and then you multiply what's in them together, because when they're adding between the parentheses, that means multiplying the stuff inside the logarithm. So basically at this point, we have gone through and hit pretty much every type of problem that's on the test. That's including that homework that I went over at the beginning of the class on the equations. So I'm going to go back and hit some of those again here in a second. But basically, when we run out of time here, if you guys run out of time and don't get through all of these, that's fine. You'll be all right from this point on. You should have a good base for what the test looks like. But I'm going to keep throwing up problems on here. As many as you guys can get through, as quick as you can get through them, that's going to be great for you, because that's going to help you out see more problems, more practice for the test. If you don't get through them, you can go through and watch this video at home, and I'll probably send out a reminder text. You probably already gotten it by the time you've seen this video, that you can watch all these videos at home on your own as well. So let's hit a few more problems. Here's a couple of expand and condense problems again. Take a look at these and see if you can get them. Pause. All right, here's your answers. All right, so here's a problem for you. You buy a TV on a credit card because you didn't pay attention to what Mr. Harrison told you in class. Interest on a credit card is added monthly a lot of times. That TV costs you $2,999, and your interest on your credit card is 19.3% interest. How much do you end up paying for the TV if it takes you 2 years? Now, Be careful with this in real life. I'll go ahead and warn you, as you make payments, it also affects that when they start paying down on the balance, but you're still being charged some interest. Some accounts are set up where they go ahead and they figure in the interest immediately with how long it's going to take you to pay it off, such as buying a car and things like that occasionally. When you buy a Harley Davidson, I'll tell you that's what they do. So be careful with that in real life. When you do this problem, it's going to be not entirely accurate because you will be paying some of it down as you go through that 2 years. So try this problem. Go. Pause it. All right, so there's your answer. $4,398.25. If that interest is added 12 times in a year, monthly, that's when you use that little formula that has that over n divided underneath the rate, and 12 times the 2, or the n times the time, as your exponent. You're paying a lot more for that TV than you really should have, and you could have bought it with cash if you listened to Mr. Harrison. You didn't get a car loan and things like that. All right, here's your next question. Solve this equation. Pause it. All right, here's your solution. Add the 1 over, divide by 2. Then you change it into that format. Remember we talked about this base raised to this power equals this number. Guys, the base e is the logarithm. That's the natural logarithm. Base e to the x power equals 5. So all you got to do is take out your calculator then and do the natural log of 5 is 1.609. So you're changing from exponential to logarithmic form. It's the opposite when you're solving a logarithmic equation. You go from logarithmic form to exponential form. All right, so in class we did an example of Newton's law of cooling. You've got some soup that you pull off the stove at 212 degrees Fahrenheit after it's boiling, and you want it to be safe to eat at 100 degrees Fahrenheit. The room temp around it is 72 degrees. The cooling rate of this particular soup is 0.03. Use Newton's law of cooling. You may have to look in your notes for your equation to help you figure out how long is it going to take before you can eat your soup. Pause it. Pause it. All right, so here's your solution. Use that Newton's law of cooling function. It's a pretty ugly function, but you plug in your final temperature that you want. You plug in your beginning temperature subtracted in your room temperature here. Then you have e to the rate times time, but there's a negative there. Don't forget that negative or you'll mess up your whole answer down here. So then you have plus your room temperature over here. You subtract 72, you get 28. You divide by the 140, you get 0.2, and equal to this e raised to the negative 0.03t. Very similar to this equation that we just did. You take the natural log of 5 equals x, because this base raised to this exponent equals this. This base raised to this exponent equals this. So we do the same thing here. This base e raised to this exponent equals 2, or 0.2, excuse me. So then you take out your calculator, the natural log of 0.2, divide it by the negative 0.03 to get t by itself, and you get 53.6 minutes, or about 53 minutes and 36 seconds. Is how long you will have to wait before your soup is cool enough to eat. All right, here's your next question. Solve this equation. 2 times the natural log of 3x equals 5. Pause it. All right, here's your solution. So when you look at this, I gave you 2 options here on this one. You can do it on the left where you divide by the 2 in the front first, and then you do your definition of a logarithm. Base e raised to the 5 halves equals 3x. Divide by 3 and then use your calculator to find the answer. Or you could take that 2 that's in front of the logarithm and make it the exponent for 3x, so it would be 9x squared. And then you do your base e raised to the 5th power equals 9x squared. Solve it by dividing by 9, taking the square root. Either way you're going to end up, because e to the 5 halves on the left side over there, or the square root on the right side, means you have to put a plus or minus, because that wasn't there in the problem before. And so if you do that plus or minus, you're going to have a positive or negative 4.061. And if you look back at the original problem up there, you're not going to be able to plug in the negative, because the negative will not work in the original problem. So negative is an extraneous solution. All right, guys. I apologize if you made it this far. It's pretty late on Saturday evening for me to be here at school. If you can't see down in the corner, you probably can on this video. I am ready to head home. So on page 487 through 491 in your book, there's some review from the chapter. There's a few section reviews, and then 491 is an actual chapter test example. If there's any of those problems in particular in there that you want me to go through, that you want me to show you how to do, there's a few of them that we didn't do. So just email me, and if I have time this weekend, if I have time over the next couple of days, since this will be given to you guys on Tuesday, I'll try to go through and do some of those problems on YouTube. Or if you just want to come see me, ask me questions. If you want to come ask me questions about your quiz that we just took, you can come ask me some questions about that, and I'll let you see what you made and how you did on those things as well. If you made it this far, at the end of class, I told my substitute to hand out to you guys that finished the quiz. I told her to hand out the quiz to you guys. I've also told her that if you have time, if you make it this far, you don't have anything left to do on this review, if you have time at the very end of class, there's a couple of you who have not finished your quiz. You can finish your quiz now, but you need to be in separate seats, away from each other, not still in your groups, and make sure that the rest of you guys are quiet for those guys that are finishing up their quiz. Other than that, there's videos all over YouTube of mine, and if you find some other ones that you need to review, go for it. Watch this thing over and over again, practice them, pause them, make sure you got them down, make sure you can do these types of problems. But make sure, again, as always, guys, that you know the process. The process is the key. Not just can you do problem number 10 in your book, but can you do the process that helps you also do all the other ones just like it on your test. So, if you need anything, again, just email me, let me know. I will do my best to accommodate you and help you out as much as I possibly can. Have a good day, guys, and be ready for your test.